Hi everyone, welcome to video 15. We're going to be talking about exponential equations today, and we are looking at section 2C from your textbook. Alright, in the MYP4 book that's on Google Drive. Alright, so what we're going to be taking a quick look at is we're going to be looking at now solving exponential equations. So what is exactly an exponential equation? Well, an exponential equation is really an equation in which the unknown part, or the variable, okay, seems to occur at the part of the exponent. So up till now, we've always looked at situations whereby we have always x squared, or x cubed, or a to the power of 1/4, etc. Now what we're going to be taking a look at is we're going to be taking a look at situations where our unknown, or our variable, is no longer found in the base, but it's going to be found now in the power. And what we need to do is we need to solve for the value of x or y or z or whatever that power may be. We need to solve for it in the power as opposed to in the base. So just to give you a brief example, we could say, well, we've always solved regular equations. So for example, we've had 2x plus 5 is equal to 13, and then I can just solve for x by saying 2x is equal to 13 minus 5. 2x would equal 8, and x will equal 8 divided by 2, which equals 4. So we have solved for 4, or for x in this problem. Now what we're going to end up looking at is finding what our value of x is, but it's no longer in a base, or in a linear form as it is in this case here, in a linear equation, but it is now found in an exponent. So that would mean something along the lines of 2 raised to the power of x is equal to 8, for example. Now, this does not seem like a particularly difficult question, in that we should basically know just by taking a look at this without even really trying to figure anything out, that some number, or rather 2, raised to some unknown value of x has to equal 8. Well, that number can be nothing but 3. Since 2 to the power of 3 equals 8. Now that's a simple enough question, but obviously the questions can get a little bit more complicated. So what we're going to be looking at then is that an exponential equation then is one that's in which a variable occurs in the exponent. Now, an exponential equation where each side can be expressed in terms of the same base can be solved using a specific property, and basically the property says this. So if I'm just going to move on now, and what we're going to be looking at is simply this, that if I can bring, for example, if I have b raised to the power of x equaling b raised to the power of y, because my bases are identical, what this is basically saying in this property is that if my bases are identical across the equal sign, that I can really disregard those bases altogether and then just say that x equals y. So, as an example, let's take an example as here that we have in our chart. If I have 7 to the power of 2x plus 1 is equal to 7 to the power of 3x plus 2, since the two bases are identical to each other, they have a base 7 and a base 7, then what I can actually do is I can disregard these two bases, and I can simply just say then that 2x plus 1 is equal to 3x minus 2, actually, not plus 2. And so that we end up getting 1 minus 1 plus 2 is equal to 3x minus 2x, and therefore 3 is equal to x. So that tells me that in order to make my left-hand side of my equation equal to my right-hand side of the equation, the value of the x up in the exponent would have to be equal to 3. All right, so let's take another look at another example. So again, taking a look at the next example, we could say that 3 to the power of 2x minus 1 is equal to 27 raised to the power of x. Now, these don't apparently look identical in that I have a base 3 on one side and I have a base 27 on the right-hand side. However, the base 27 can be brought down to a base 3. In base 3, it can be written as 3 raised to the power of 3. But recall that it's also raised to the power of x. And therefore, by using the power to a power rule, this goes to 3 to the power of 3x. Now, my left-hand side of the equation still remains the same. I now have the same bases on both sides, so that I can say that I can get rid of the bases, I can disregard them altogether, and I can simply say that 2x minus 1 is equal to 3x, and therefore negative 1 equals 3x minus 2x, and therefore negative 1 is equal to x, or x equals negative 1. Now, if I want to take a third example, the third example that they give us here in the chart, the third example shows us that we have 5 raised to the power of 3x minus 8 is equal to 25 raised to the power of 2x. Again, I don't have identical bases, but I can bring them down to the same base, so that I can say 5 raised to the power of 3x minus 8 is equal to 5 squared to the power of 2x, so that I end up removing or disregarding my bases of 5, and I end up with 3x minus 8 is equal to 2 times 2x, which is 4x. And from here, all I need to do is say negative 8 is equal to 4x minus 3x, so that x equals negative 8. So I have figured out that in order to make my left-hand side equal to my right-hand side of my equation, the value of x would have to be equal to negative 8 in order to make the left-hand side equal to the right-hand side. All right. So let's continue now and see if we can do some more examples. Let's do a couple of more examples here, such as 3 to the power of x equals 27. So I bring these down to the same base of 3 to the x equals 3 cubed. Since 3 cubed equals 27, because my bases are now the same, I can disregard them, and therefore I know that x equals 3. If I look at the next example, I've got 2 to the x equals 16. Well, 2 to the x is equal to 16 can be brought down to a prime number base of 2 as well, so that it goes to 2 to the power of 4. Now, because the bases again are identical, I can disregard them, and I find that x is equal to 4. If I look at the next one again, I've got 5 to the power of x is equal to 125. Let's bring everything down to a base of 5, and 125 is really the same thing as saying 5 cubed, so that x is equal to 3, since the bases of 5 are going to cancel themselves out or be disregarded. We look at the next one, 3 to the power of x equals 81. Well, 81 can really be rewritten as 3 to the power of 4. And that tells me that because the bases are identical, the 3 and the 3 cancel themselves out, and so we know that x is equal to 4. Now, looking at the next one, the next few tend to get a teeny bit more complicated, but I assure you they are not that challenging. So let's take a look at the next one over. I've got 3 to the 2x plus 1. Well, I can't bring that base down any further, but I can certainly bring down the other side, the right-hand side, down to a base of 3, which is 3 cubed. The bases are now identical. I can disregard them, so I have 2x plus 1 is equal to 3, so that I have 2x equals 2, and therefore x is equal to 1. If I now do the next problem. The next problem has a base 4 on one side, and it has a base 8 on the other side. Well, I cannot change the base 8 into a base 4 because 4 squared does not give me 8, but it gives me 16. So my best bet is to bring both bases down to their simplest form, and their simplest form is their prime number base of 2. So I can rewrite this as 2 squared to the power of x plus 1, and that equals 2 cubed to the power of 5 minus 2x. Alright, now in having done that, my bases are dealt with. I don't need them anymore. And I have 2 bracket x plus 1 is equal to 3 times bracket 5 minus 2x. So that in the simplification here, it's quite easy. All I do is FOIL or I distribute. I get 2x plus 2 equals 15 minus 6x. So that I can say that 8x is equal to 13. So I have 6 is brought over to the left-hand side, so it goes to positive 6. So 8x is equal to 15 minus 2, which is 13. And therefore, I end up getting that 8x equals 13, or x is equal to 13 over 8. So it's not surprising that we can have problems whereby we will have fractions and not whole numbers as answers. That is more than possible. Okay, let's do another example here. Now, this one requires a little bit more movement. It requires a little bit more manipulation. So I would start by saying that the square root of 7 I would rewrite in exponential form as being 7 to the power of 1/2, which then gets divided by, well, 49 needs to be also adjusted in that it can be rewritten as 7 squared to the power of x times x. So it's divided by 7 to the 2x, and that equals 7 to the power of -1. Alright, now having done that, I can actually bring these two together because I can only do this one-to-one relationship only if I have one base on one side and one base on the other side. So I can really rewrite my left-hand side as 7 to the 1/2 minus 2x, and that equals 7 to the -1. Well, at this point, my 7's now, I only have one 7 on the left-hand side. I've only got one 7 on the right-hand side. So I can just now disregard them and write 1/2 minus 2x equals -1. And I can say 1/2, just going to bring this up a little further, I can say 1/2 plus 1 is equal to 2x. And now I simply isolate for x. So it's 1/2 plus 2 over 2, getting a common denominator, equals 2x. I get 3 over 2 is equal to 2x, and therefore x becomes divide by 2, it goes to 3/4. And there's my solution for that last question. Now, what I'm going to do is I'm going to try to give you a couple of other questions that are a tad more challenging. So I'm going to give you a couple of other questions. Let's see if I can find something that's worthwhile. I'm going to pick something along these lines. Let's do a couple of other ones. So if I have 2 to the power of 1 minus x, and that gets multiplied by 8 raised to the power of 2 plus x, well, that's equal to 16. Okay, so again, I've got an issue on my left-hand side here, where we need to solve for x, of course. I have an issue on my left-hand side in that I've got more than one base here, and I don't want to have more than one base on each side of the equal sign. So I'm going to start bringing everything down to a base 2. Remember that our prime number bases are what we're always looking for. So we're always going to end up bringing our bases down either to 2, or 3, or 5, or 7, or 11. We're normally not going to go beyond 7. However, keep in mind that all the prime numbers are going from 2, 3, 5, 7, 11 to 13, 17, 19, 23, and so forth. Okay, so here, because my lowest power, or my lowest base, is 2, then I will say 2 to the power of 1 minus x gets multiplied by 2 cubed, multiplied or raised to the power of 2 plus x, and that equals 2 to the power of 4, since 16 is the same thing as saying 2 to the power of 4. So now, because I've got two bases here of 2, well, I'm going to try to get rid of them, but not just yet. I'm going to do 2 to the power of 1 minus x multiplied by 2 to the power of 6 plus 3x, and that equals 2 to the power of 4. Now, I can combine these, because it's multiplication and the same bases, we've got the same bases, I can combine these and turn them into 2 to the power of 1 plus 6 minus x plus 3x, and that equals 2 to the power of 4, so that I have 2 to the power of 7 plus 2x, and that equals 2 to the power of 4. I now have a one-to-one relationship in terms of I've got one base on each side of the equal sign, and therefore I can disregard these, and I end up with 7 plus 2x is equal to 4, so that I can say 2x is equal to 4 minus 7, and then 2x equals negative 3, and x equals negative 3/2. So therefore, in order to make the left-hand side of my equation equal to the right-hand side, that means that I will have to make x equal to negative 3/2. Okay, that's it. I don't really have much more to say, with the exception of, well, what if I cannot bring both sides of the equation down to the same base? So let's take a look at this example here. So if I have this example here, 5 to the x equals 7. Well, 5 has one base and 7 is another base, and I cannot possibly bring these two down to the same base. Okay? So what I would have to use, and it's not a discussion that we'll have this year, but it's a discussion that we'll have next year, but it's just so that you have a heads up, is that when we can't bring the bases down to the same base, then what we end up doing is we end up using logarithms. So what we do is we multiply both sides by logs. Log of 5 to the x equals log of 7. And then we use the laws of the logarithms to show us, we use the laws of the logarithms, and which you don't know yet, and then we isolate for x, so that we can get the log of 7 divided by the log of 5. Now, if I were to open up my calculator this minute and actually perform this on my calculator, which I'm going to do right now, I'm going to show you, I would end up doing, what I would end up getting is I would go to the log of 7, and then I would divide that by the log of 5. Enter. And that tells me my answer is 1.209, etc. So x is equal to 1.209, blah, 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 whatever the rest of it is. Now, if I took this and I replaced it back into the value of x, if I took the value of x here, let me rephrase that, and I replaced it back into the original equation, then I would have 5 raised to the power of 1.209 blah, blah, blah is equal to 7, and my left-hand side should equal my right-hand side. So again, I'm just going to open up the calculator, and I'm going to do 5 raised to the power of, and I'm going to put in 1.2090606 1955. I didn't have to put that many numbers, but I just wanted to be consistent. I enter it, and lo and behold, I get 6.99999, which really, when rounded up, goes to 6.999, repeating, is equal to 7, and 7 does equal 7. Now again, you are not responsible for this part. of the lesson. Okay, so all you are responsible for is knowing how to work out problems, how to work out equations or exponential equations where you can bring everything down to the same base. When we are working with bases that are different and that cannot be brought down to the same base, then we would have to use the next step, and the next step would be using logarithms, and that won't be until next year. All right, so for your homework, you are expected, or classwork, you are expected to complete exercise 2C from the MYP, oops, I think I made a mistake there, the MYP4 textbook. So it's the MYP4 textbook, and you are to complete numbers 1 and 2, all of it, in exercise 2C. And then I would like for you to go back to that really long handout with the questions that went from 1 to 150, and it was the indices in standard form handout, which is on Google Drive. And I would like for you to go over questions 82 through to 118, and then all of question 122. These are going to be questions that you'll be doing in class. Okay, but if you want to get a heads up and you want to start working on it, you can. But this is classwork for the next class. See you next time.